So let's give you an idea of what capacity looks like when you're storing all these ones and zeros. So if you are looking at a kilobyte, so now you know kilos 1,000, that is equal to 8,000 ones and zeros. All right, so if you have if you have a kilobyte, 1 kilobyte, that's equal to 8,000 ones and zeros. That's about a page worth of words and letters. So when you type up your essay, you got a page worth of it. They're about 1 kilobyte. All right, 1 megabyte. That is equivalent to about 8 million ones and zeros. That's a good number of ones and zeros. So you have a choice. You have to pick. It's not all of these three as an example. It's one of these. You can choose, oh, okay, I'm going to use those 8 million ones and zeros for 10 large photos. Or you might say, no. I want to have 10 minutes worth of music only. That's what you can use the 8 million ones and zeros for. Or you can say, no, I don't want either of those two. I'm going to use up all the 8 million ones and zeros for about 1 minute of video. And that is how much 1 megabyte will allow you to store or keep, approximately. And then finally a gigabyte. So 1 gigabyte is equal to about 8 billion ones and zeros. So what can you do with 8 billion ones and zeros? Well, you can represent and store an entire movie or a film. One movie or film. You need about 8 billion ones and zeros. Alright? So let's test out your understanding of capacity here with some of the prefixes we've been talking about. This is no different than the last table chart you just saw. I just added 2 rows here, top and the bottom. I want you to guess what goes where the question marks are. Alright? Let's start at the bottom here, just to kind of give you some easier start. So terabyte, how many ones and zeros would a terabyte be? Again, look at the pattern, look at what we've already gone over and see if you can figure that out. Give you about 2-3 seconds here. Okay, so here goes. You should have come up with 8 trillion ones and zeros. Right, so 8 trillion ones and zeros. It's pretty much only used for, right, storing like a lot of these things up here. It's a lot of data. Just to give you an idea, 1 terabyte could hold about 500 hours of movies or pictures. One terabyte could hold about 300,000 pictures. Right, it's a lot. So much you may not even use up. Alright, now let's go to this one. So let's see if you can figure this one out. This is a little bit trickier, but hopefully you'll figure it out. Take a look at the pattern and see what's going on here. See the connection between the things that are in bold here. That's kind of a hint there. See the bold part and how they're connected to the number value. So I'll give you about 5 seconds there. See if you can figure out what a byte is. Alright, so hopefully you caught on that the prefix gives you an idea as to the number of zeros, right, that you use. So tera, giga, mega, kilo, all refer to the number of zeros. So there's no prefix on this one. So what happens if you get rid of all the zeros? What are you left with? Well, we're left with the 8. So if you guessed that a byte is 8 ones and zeros, you are correct, right? A byte is simply 8 ons and offs. So those are the signals. A byte is 8 ons and offs. Alright, and then we just want to end with showing you what a byte and a kilobyte looks like, just so that you're clear. Remember, these are just the signals, on and off signals, and we're using 1 and 0 to represent on, 1, off, 0. Alright, so let's just do a random byte. So if you recall back from the last thing we just saw, a byte is 8 ons or off. So 1, 2, 3, 4, 5, 6, 7, 8. So we just made that up. It doesn't matter. It could have been all ones or all zeros. So this is the signal. Off, on, off, on, off. Right? So that's 1 byte. Just want to make sure you can see that. Equals 1 byte. I hope that is clear. I can't make it any clearer, I think. Let me just do another example just to be clear, or just to make sure that you've got another example. So here's another. 1, 2, 3, 4, 5, 6, 7, 8. That's also a byte. There's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 signals that all happen to be on. Alright, so now that's what 1 byte looks like. A kilobyte, if you recall, kilo means 1,000, right? So we need 1,000 of these. We need to write out 1,000 of these. This is just 1 byte. We want 1,000 bytes. So what I'm going to do is I'm going to highlight it, copy it, paste it. That's 2, 3 bytes, 4 bytes, 5 bytes, 6 bytes, 7 bytes, 8 bytes, 9 bytes, 10 bytes. Great. Now I've got 10 bytes. I need 1,000 of these. So that's 10. I'm going to copy that. I'm going to paste 20, 30, 40, 50, 60, 70, 80, 90, 100. I have 100 bytes. 100 bytes. I'm trying to get to 1,000. 100. So I've got 100. I'm going to copy those. And you know what? I'm going to shrink this down. So I've got 100. I'm going to make them size 6 so that they fit here. 100. Copy. Paste. 200. 300. 400. 500. 600, 700, 800, 900, and 1,000. Alright, so let me expand this text box. This is what 1 kilobyte looks like. 1 kilobyte. If you recall, these are the signals, right? The on and off signals that exist behind a piece of paper or an essay that maybe you typed up for a social studies or an English class. Just hope that helps you visualize what 1 kilobyte, 1,000 bytes looks like.